Elasticsearch is a search backend primarily. It is a distributed system that can serve millions of search requests parallelly. You could build search features like autocomplete, typo correction, did you mean, or synonyms, or fuzzy searching, script-based queries on it. However, for folks who are into all of this and want something very simpler, Elastic has abstracted all the complexity and built something like App Search, which has a search console to manage the relevance and synonyms, and also have other features like a crawler, curations, etc. Now in this video, we'll take a look at the Elastic App Search and how to build a search engine. Let us quickly start at elastic.co site, and so that you could also learn various things in the site as well as where to download the product and how to build it. We will also see how to do a cloud deployment and start building the search engine from the scratch. So initially, when you head over to elastic.co, you will be seeing products, customer, learn, and various menus. And you will see three specific products like enterprise search, observability, and security. Now, if you haven't watched my previous video, please do watch, where I explained in detail about what these three things mean and what is elk stack and how Elasticsearch literally works. So app search comes under the Elastic Enterprise Search bundle or solution, and wherein it is just a layer that is sitting on top of your existing Elasticsearch cluster and helping you manage this search engine, search console, and everything. So to download this enterprise search bundle, which contains the app search, so you either just click try free, which will take you through the downloads and download the product, or you could also go ahead and like go to the cloud and initialize and create a cluster, where in the description you would get a link how to get started with all the resources and where to get started and create a cluster. So to download it and run it on your laptop, you just need to download the Elasticsearch based on the type of the OS that you are running, or you could run it on Docker as well, or Kubernetes, and then like download the Elastic Enterprise Search bundle. At each downloader, whenever you see this page, there are also description of how to get started each one of this. In cloud, of course, you don't need to do all of this configuration, because when you create a deployment, everything will happen as easy. Now let us quickly head over to the cloud and see how you could get started with Elastic Cloud as well as the app search and building a search engine. Now this is a login page, cloud.elastic.co/login. I'm just logging it with my credentials. You could use Google or Microsoft logins if you already have an existing social login. And then this is this cloud console that you see here with the cloud deployments here and a bunch of documentation, release news, and other resources to go ahead and learn more. We'll click on create deployment, through which we'll create a deployment of search, and then choose whatever the configuration that we want to do. If you see here, I have multiple bundles, or like deployment templates we call. And say for example, if I choose Elastic Enterprise Search, and it'll show me like clouds, and I could choose a cloud of my choice. I can choose something which is very near. I'm choosing Google Cloud and Mumbai, South Asia. And then the version of the Elasticsearch cluster, the latest one is 7.12.1. And then you name as you like code for cause. And you could also use API key to create an equivalent API request, and then fire up that. But in the interest of time, I'm just clicking on create deployment so that you could create it. You could also click on customize to customize this template, like what and all, specifically that what size, what storage you want to create. You will be shown a username, password. Now don't worry, you could continue without downloading it. It automatically logs you into the cluster because we use an SSO here, but alternatively you could download and get a CSV file just in case. If you want to reset your password, you could go to the security tab here and click on reset here, which will appear in a minute once you have the deployment created. Now let us wait a few minutes until the time that the enterprise search cluster gets deployed. It would only take a few minutes to get started. As you could see, we could see more information here already, like something called a cloud ID, the deployment version, deployment status which is being created, and then you have a deployment name that you would refer whenever you are talking to someone like support, and then a current endpoint alias, wherein which gives you an alias for your API. Say for example, if I want to refer one of these for calling an API, then you would see that code for cause .es.asia so and so so and so, and then you would refer this particular alias name actually, so that you in your there is no different sort of unique IDs or some alphanumeric IDs that you need to use. So you could see that the enterprise search cluster is just getting built. Just let's wait for a few more minutes and then we'll be up, and the cluster will be up. As you see that the enterprise search is built up, and then I'll just click on the link to open the cluster, and then to open the page, and then like thereby we could start ingesting data and creating this search experience. If you see inside this enterprise search bundle, you would see two specific names. One is Elastic App Search, one is Workplace Search. So what are these and how different it is? So both are search engines, both cater to your needs, like when you put data and it will give you a search bar to you for you to access. But App Search is a bit different than Workplace Search. As the name suggests, Workplace Search unifies all your Gmail, Slack, Salesforce and Confluence, Jira, all of these tools that you use to or even GitHub to collect all the PRs, issues, and then make it in a single pane of glass so that you could search through all the resources. And it also has APIs, it also has all the connectors, but we are not literally discussing that today, and we're going to talk about more about Elastic App Search, through which we are going to build a search engine. When you click on Launch App Search, you will see the app search being loaded, and then you'll also see an onboarding experience. You can skip onboarding experience and again go do the same thing, but I'm gonna take you through the onboarding experience here. Like I have a data set which has all the engineering colleges and polytechnic colleges in India. So I'm gonna name my like that's the search engine I'm trying to build. So I have the data and I'm trying to build a search across it, and college engineering, I'm just putting it. You could also choose, suppose if your data has in different languages, and you might want to choose that and specifically as well, so that is supported. So I'll just click continue, and then I'll be asked some more details, like how do I want to ingest the data. There are multiple ways. One you could paste the data, like there is some sample data set that is given here. Of course there's a limit of 10 MB around, so you just need to see that. Or you could also upload a JSON file, which I'm going to do now. If you don't want to use both of these, and if you want to like go with other options, there are some more options as well, like using an API. Of course you need an read API key, which is given here. So this is an example of how you would ingest the data into the app search. So this is an API request, we are using curl here. So, and this is the alias, I mean the name of the engine, and how do you need to call an API. And if you are not even interested in calling an API, and if you want to look at crawling the site from a public place, you could anyway use the web crawler, through which you will simply crawl the data and ingest the data into the app search, which we'll also see in the coming session. I'll click on upload JSON and try to drag and drop a JSON that I already have, like colleges.json. It will take a minute or so to kind of ingest all the data that is there in this particular JSON file. Let us wait. Okay, now that it says the data index successfully, you could click on the visit dashboard, which will take you to the search engine console. Let us click on the visit dashboard, and thereby you will be directly taken to the specific place wherein you could manage the settings and look into all of that. So there are multiple options here, which says engines, meta engines, credentials, etc. As the name suggests, you could better explore and understand by yourself. But if not, you could go ahead and click on these. I mean, if not, I'm I'm just gonna explain you something like meta engines, wherein if you have multiple search engines and you want to drive a search request to multiple search engines at single point of time, you could also do that. So that's what meta engines. And credentials is like as simple as it as the name suggests. You can generate new credentials for your API and etc. Now I have created engineering colleges data is search engine, and then it contains a certain number of documents right now and a certain number of fields. And I'll click on this so that we'll get into the system. As you see, the number of documents is continue to increase because we have uploaded a very big file which contains like more than 5,000 documents, and it's continuously ingesting the data as we speak, and it'll become as big and big and big. So meanwhile, let us explore this particular data. So we have done we have around 2,600 documents indexed, and there are queries and operations, etc., that has happened till now. So you could also go and look at the analytics of the search engine, but we'll not target that. We will come back to understand what is the schema like and how does that schema look like. So initially, when you upload this data into it, it will try to find out what are the names in the JSON. Like each JSON document will have attributes, right? So it will find that as a schema and then shows you that that particular schema and like what data type it has identified. So if you disagree, and if you say that okay, average fee should be a number, and you select that, and then you kind of like confirm types, then it will try to change the data structure and try to organize it in a different format. So I'm just gonna confirm types, and then it will kind of like adjust everything. So I also see that there is an error because saying like several documents have conversion errors. So if I click on view errors, probably it will show me something else. So let me go, maybe there is a fault in the data. Let me go and like click on update types and say that the schema is updated. So maybe there are some average fees which is not a number and which is probably an string, or it's empty probably. Okay, so you should do that data sanitization thing. I'm just picking up a random data set on the internet and then trying to build a search engine around it. But the data quality is decently well. So I just want to highlight that as well. So this is the schema that you have. And then if you want to take a look at the documents, you can go to the documents use case, and like wherein UI, and then like you could see how does the document look like, what are the information that is there, etc. Now the important thing is like to build a search experience. So to build whenever someone wants to search something, and then you want to add an information. Say if I want to search a college in Tamil Nadu, something like VIT, and if I type of VIT, whether I'll be getting the relevant details, or I'm getting some VIT that is not related. It seems I'm getting the right VIT. You could also see the score of the document. Like when I search, you should see that the score is 10, here it is 9, here it is 8, and the score drops as and when the relevancy reduces. Like there is Vithal Das Polytechnic, but it has VIT, but it is not actually the VIT, right? There's a Vita, but it is definitely not the VIT that I am looking for. So how does it do? Is there any machine learning? No, it simply uses some data structures and also Elasticsearch queries to help you build this particular stuff. It uses an algorithm called BM25 in the relevance tuning, or if you have heard of TF-IDF, term frequency and inversion document frequency algorithms, please take a look at that. Those are interesting to learn how the scoring and all of this happens in Elasticsearch. So this is the score, but I'm not still happy, and I want to do more. Like say for example, if I want to find out a specific, I want to give priority to more a specific type of results than randomly searching, bluntly searching all the documents, all the fields. So that is where your relevance tuning would come in, and that is where you could kind of like put in a search, like say suppose there is this if I have to choose a name, I choose name like Gayatri. So there's a remote college in a tier 3 town, like in my place, and then I'll choose something like Vishakhapatnam, right? So this is a place, and then it shows me the right one, but I always want to give more priority to so people would search a location, people would search a name of the college. So I want to like give more weightage to this particular term so that it gets searched. You could also like choose to not to search on top of a field. You could do all of that. Now remember, while I do all of this, everything is again available as an API for you to change. So all of these relevance settings, etc., is available on a wait. So App Search adds all of these details and maintains and manages this Elasticsearch cluster. If you are building all of this by your own on Elasticsearch, it will be taking a more amount of time, and you don't have all of these console. But that's why App Search is much easier and not so difficult to configure and look at things. So I have this particular, you see the score changing as and when we change the details here. That is an important thing. It will take a bit of time sometimes to reflect what we are trying to do here. So that's how you manage to get things around. You could also choose what data to be results to be given out in the search result. You might not want to show everything in your data, and you want to hide only some things and show some things in the search engine, like the link to the college and some description and where the college is and some average fees or something like that. So you could do all of that. Now coming to the important part of the search is like testing the queries. So you have a query tester wherein you kind of like test for say if there is a college on my name. Yeah, of course, I think there's a college on my name. So you could go and look at names of specific colleges and names specifically which is related to a specific region or etc etc. Now you could test the query, you could find out what is a query body that is getting fired, etc. here. Now over the period of time, you might also, like some colleges have acronyms, right? Say just like BKC, which is Bandra Kurla Complex in Mumbai, or just like IIT, which is like Indian Institute of Technology. Now if I type IIT, maybe there is IIT already, but if I want to name Indian Institute of Technology, like to Indian Institute of Technology as IIT Patna, right? Indian Institute of Technology, Indore, Dharwad. So if I want to name this acronym, so I could go to something like synonyms, like as the name suggests, it is a synonym for an acronym or something similar. Like, so for example, some people call biryani in a specific name or a slang, and some people use the same biryani, probably might pronounce biryani with a different name or something. So you could use the synonym to do all of that magic. So I'm using, if someone like say you could use any terms, any order, like say Indian Institute of Technology, Indian Institute of Technology, and I use IIT, both are same, right? If I use IIT Patna, and it should sound the same. So now if I come back to the query tester and then I find out, like, IIT, it might take a while to reflect this relevancy changes sometimes, and you just be wary of that. Like I'm just using IIT Patna, but it still gives me the right details. If I'm using IIT Indore, it still gives me the Indore University. If I use IIT KGP, probably it might not give me the Kharagpur, because it doesn't know KGP means Kharagpur. But if I type Kharagpur, it might give me right name, right? It might give me the right college itself. Okay, maybe Kharagpur is not here in the data set. So these are the things that you could do with synonyms, right? You could add as many as synonyms here. Similarly, you have curations through which you could also like kind of do a specific query, like say NIT. Not just acronyms, any queries, like say for example, if you want to create a query like National Institute of Technology, but you want to always show a specific college whenever somebody types NIT. Like say if someone types for Nike, you always want to show the shoes first. If someone types for a specific brand, you always want to show a specific like someone types Apple, most people buy iPhone, so you might want to show iPhone there. So that's what you could do. Like say if someone types NIT, I'm just gonna like showcase some college that is there here, like NIT Polytechnic in as the first one, irrespective of the scoring and all. So always that comes the first, like that is the configured thing with all of that. So you could do all of these interesting things, and whenever someone searches, you will see that particular search coming up. Now over to the search experience, building the search experience. Now all of this is great. This is like backend to what the application is doing. The user only sees the search box and types the results, and then like someone behind the screen managing the search engine console, optimizing according to the user, right? So how do you kind of create the search experience itself? We have a solution to that as well. So we have an open source project called Search UI, which is a React library which helps you to build all of these applications, and which gives you a search experience, which gives you a search bar, and you could put your own CSS and build on top of it. Of course, there are APIs, and you could use Flutter, you could use all these mobile React Native, or if you could use Angular, or you could build a desktop app. You could do all of that because it's an API oriented thing. Elasticsearch and AppSearch both have APIs. You just need to do that. So I'm just gonna show you this new reference UI, and then we'll quickly look at the analytics as well. So as you see here, I have a college name as my, I'm going to give my college name as a title. You see on on the right side here, I'm selecting a specific name, and then like filter fields as like I want to filter based on average fees. I want to filter based on the college type maybe, and established year, maybe like state. Obviously it's important thing, right? And then I want my sort fields to be like obviously say campus size. I don't know how relevant it is, but then like I just want to use that. And then okay, I'll choose average fees, like higher to lower fees kind of a thing. And then our dataset doesn't have ID, but I could select the college name or etc. as like the ID. So if you give the URL field, whenever you click on this particular thing, it will take you to that particular website as well. So if your dataset has a URL, much better. When I click on generate preview, it generates a search engine and which you could download and again do npm start. It simply starts at localhost 3000. It's a create react app and a layer on top of it with the search UI library, and then you could see that all of these details. Like if I select Andhra Pradesh, and then it starts showing the relevant details of the colleges in the Andhra Pradesh, and then I want to rank the kind of like colleges from top to bottom, like the highest fees to the lowest fees. And then I want to like kind of also mark it as like the oldest college, so I kind of like go and see all of these interesting details that you find it out. You could also see that whenever I'm typing for like say, let me remove all of this information, and then if I am typing say NIT, I'd see the typo, I mean the autocomplete here. So there are many features like these the search UI provides, which helps you to kickstart the experience. So we have literally built a sample simple search engine over the last 10-15 minutes. So apart from that, now as we do all of this, you will also see the analytics part of how the search engine is being performed, like right from the beginning to like the time where we started, like how many queries. It will also show important details like how many queries doesn't have a result, like someone searched for something and it didn't give you a result, and you could go back and see what is that query which doesn't have a result. So you could do all of that as well. Say, and you could find out what are the queries that people were searching, and then how could you manage it in much better manner. Of course, this is an admin UI. Only few folks who are very much into to managing this thing, probably like a product manager, a developer in the team, might very well tune this over the production. Say like for example, top query with click. Suppose if you click this one, it will take you to the site. Like click through rate, you could also find out that particular information. And there is a API log if you want to see what has happened over the last minute, if someone is writing the data into the cluster, etc., etc. You could do all of that. You would also find out the status of the APIs, whether all of the APIs are giving 200s or there is a 400s or 500s. The interesting thing is like the data can be moved to the Kibana, and then you could do analytics on top of data, and that gives you more idea into what's happening into your search engine as well. Now this is an interesting thing to do, and I'm going to drop some more resources in the document here. I'm going to drop in a guide. I'm going to drop in a specific talk of mine which goes in detail into like building on top of app search. And if you have any more questions, like please comment and reach out, and I'm happy to help. Thank you.